Chefs and bakers use thousands of eggs daily. These eggs are usually purchased from the wholesaler in dozens, a dozen being a package of 12 eggs. So instead of counting out 120 individual eggs, the baker would simply count out 10 one-dozen units or cartons of eggs. In like manner, chemists report numbers of atoms, ions, and molecules using a unit called a mole. Just as a pair of any item means 2 of those items, a dozen of any object means 12 of those objects. So a mole of any object means 6.0221 times 10 to the 23 objects, if you are able to count them. Now you may ask, why such a huge number? To illustrate why a mole is comprised of such a huge number, we could give someone 12 grams of carbon-12 and ask them to count the number of atoms. Individual atoms are, however, too tiny to be seen, hence counting them directly would be impractical. The number of atoms in 1 mole of carbon-12 can be determined indirectly, however, if we know the mass of one atom of carbon. Using a technique called mass spectrometry, the carbon is ionized or charged and passed through an electromagnetic field where the abundance of the ion in a sample is calculated. The mass of a carbon-12 atom has been found to be equal to 1.99265 times 10 to the negative 23 grams. Therefore, the number of atoms in exactly 12 grams of carbon-12 is 12 grams divided by 1.99265 times 10 to the negative 23, which is equal to 6.0221 times 10 to the 23. This is called Avogadro's number. This heap of 12 grams of carbon therefore contains Avogadro's number of carbon atoms. Therefore, the mole is the amount of any substance which contains as many particles, be they atoms, molecules, or ions, as there are atoms in 12.000 grams of carbon-12. 1 mole is the amount of substance that contains Avogadro's number of particles of that substance. When speaking of the mole, we must specify the elementary entities that we are referring to. That is, atoms, molecules, ions, electrons, other particles or specified groups of such particles. For example, oxygen occurs in nature as a gas, O2, which is a molecule containing 2 oxygen atoms. 1 mole of oxygen atoms equals Avogadro's number of oxygen atoms. 1 mole of O2 molecules equals 2 times Avogadro's number of oxygen atoms. Note that 1 mole of O2 molecule equals 2 moles of oxygen atoms. Examples: how many atoms of hydrogen are present in 1 mole of H2 gas? 1 mole of H2 equals 2 moles of hydrogen atoms. 1 mole of hydrogen atom equals Avogadro's number of hydrogen atoms. Therefore, 2 moles of hydrogen atoms equals 2 times Avogadro's number of hydrogen atoms. So, 1 mole H2 is equal to 2 times Avogadro's number of hydrogen atoms. How many molecules of HCl are present in 0.4 mole of HCl? 1 mole hydrochloric acid equals Avogadro's number of molecules. 0.4 mole equals 0.4 times Avogadro's number of molecules.